Welcome back to the shop and to the channel. A few weeks ago I got an email from somebody from ArcCaptain asking me if I'd be willing to do a review of sorts of their MIG 200 welding machine. I had a welding project coming up and I said sure, I'd like to check it out and I'll use it to work on this project I have. So they sent me one of their MIG 200 machines, full transparency. They sent this to me free of charge, and the only stipulation really was that I make a video using the machine and talk about it. Overall, it seems to be a decently constructed machine. It comes with a number of drive rollers for different size wire, as well as rollers for using flux core wire. It came with some extra tips and a nozzle shroud, as well as a little wrench to put the tips on and off. And there's like a warranty card and a QR code on this card to download something. I'm not sure what that is. I didn't download it. The power cord is 14 gauge wire. It's got the standard 50 amp plug on the end of it. It's about 5.5 feet long, and it comes with a short 110 to 220 adapter, so you can run this welder on standard 110 house current. The instruction manual has some wiring diagrams and some other miscellaneous instructions on how to operate the welder. Although the translation of the manual isn't terrible, there's a number of things in here that just don't translate well to at least American English. They could use a little bit of help in rewriting the manual. The MIG gun that comes with it is a reasonable size and it feels comfortable in my hand. It's about 10 feet long, and it uses a European style of connector to the front panel of the machine. The contacts for the trigger wires are built into the connector. I actually like this design quite a bit. And it also includes a hose for your gas, for shielding gas. And of course the stick stinger. This is typical that I've seen in other machines of this price range. I won't be doing any stick welding though in this video. The work clamp, or the ground clamp as some people call it, is adequate. It's better than some I've seen. At least it's got the copper strap that goes between the two halves of the jaws. Now that's everything that came in the box with the welder. They also sent me a roll of flux core wire, although I won't be using that in this video. Now, one of the ideas that ArcCaptain gave me was to compare this welder to the PrimeWeld MIG 285, since I had just done a review on it. But I kind of feel like the two machines are in a different class, so I really didn't want to compare this to the MIG 285. But what I did do is I reached out to my friends at PrimeWeld and asked them if they would send me a MIG 180 that I could use as a comparison to another welder, and they obliged. They sent me along this PrimeWeld MIG 180, which is about the same form factor as the ArcCaptain, and I think it might be a little bit of a better comparison since they are closer in their amperage outputs and in their capabilities. Now the PrimeWeld's power cord is about 6.5 feet long, and it's 12 gauge material with the same 50 amp 3-prong plug that we're used to seeing. Now the PrimeWeld will also run off of 110 with this adapter. It comes with a hose for the shielding gas. The MIG gun is what I think is a Tweco style. Now the cable says made in USA. I'm not sure if the whole cable or if the gun is also made in USA. And it uses a Miller style connector. I think that's what it's called. And this cable is about 15 feet long. There's also an included stinger for stick welding, as well as the ground clamp, work clamp, that you find on most of these machines. Included in the box is a 2-pound, I think it's a 2-pound roll of ER70S6 MIG wire. And there's some extra tips and drive rollers as well. PrimeWeld also includes a gas flow regulator that can be hooked up to your shielding gas bottle. The owner's manual that comes with it is a nice size. The type is easy to read. It's written very well, lots of pictures, and lots of tips on how to get started with welding. Got this nice laminated welding guide for you to pin up on your wall. The MiG 180 also includes this spool gun for MIG welding aluminum, and it includes a spool of welding wire. And there's also a separate owner's manual for the spool gun. And no welding package would be complete without one of these super high quality welding masks. Well, we'll get started here welding with the ArcCaptain. Now, they did send me this roll of flux core wire, and I decided I'm not going to use it. I'm going to use regular MIG wire. I do want to get an honest comparison between the two machines, so I'm going to be using this roll of 030 wire that I got from Lincoln Electric. I'll be using this in both machines. Well, before I jump right in on this project I have in mind that I want to use these machines for, I want to weld up some coupons. I've got some 3mm or 1/8" thick pieces of flat bar, as well as some 3/8 inch, about 9.5mm thick pieces of steel here that will weld up as some coupons. Well, inside the door of the ArcCaptain is a chart here to set the voltage and wire feed speed for the various thicknesses of material, as well as if you're welding flux core versus shielding gas, etc. One thing to note here, this chart is 100% metric. There are no imperial equivalents, including the controls on the front of the machine. The wire feed speed is meters per second versus inches per second on a typical US made machine. Turn on the gas here, and I'm going to set a flow rate of about 20 to 25 CFH. I'll start by cleaning off all of the mill scale in the areas in which I'm going to be welding. I'll come back and clean these with a little bit of acetone as well. I want to keep track of which welds are which, so I'm using a center punch here, and I'm marking one hole punch for the sides that will be on the ArcCaptain, and two divots for the parts that will be welded with the PrimeWeld. Put a couple of quick tacks on either side of these coupons. That stuff you see on my table, that white stuff, is actually an anti-spatter spray that I've been using, and it does a good job of making sure the little BBs don't stick to my welding table. I'm starting off here in manual mode with the ArcCaptain. I didn't keep track of all the settings here, but I started with the recommended settings and do some adjustments throughout the course of using it in manual mode, and I must say I'm pretty impressed with the quality of the arc. My welds are never as near to perfect as I'd like them to be, but this welder is actually helping quite a bit. It's pretty smooth arc, it's laying down really comfortably. The recommended settings were pretty close to what I needed. I did make some minor adjustments, but overall I'm pretty happy with the results. For the second side, I moved one of my cameras here over to the front panel of the ArcCaptain so you can see what's happening during the weld. I initially set it here at 20 volts and an 11.5 meters per minute for the wire feed speed. You can see here when you start welding, the wire feed speed display switches over to amperages and shows you how many amps you're using at that selected voltage. And just like the first weld, this one right here looks pretty good. It's laying in real nice. Again, the arc was really smooth. I was pretty happy with how it sounded and how it's laying in. I'll do another test weld here on this 3/8 stock. I'm only going to weld the one side of it. I'll use the other side for the PrimeWeld. I will say up front that this is a ridiculous test. This is too thick a material for this wire size at only 030 or 0.8 millimeters, and I don't really expect it to weld all that nicely, although in this case it did seem to lay down a decent bead. Well, for this next test I'm going to switch it over to synergic mode, and in synergic mode you set your amperage and the machine will adjust the voltage to compensate, and it's based on a number of factors, which is the wire size itself, as well as what gas mix you're using, etc. You can adjust the voltage a little bit up and down, but I'm going to go ahead and leave the adjustment at 0, but I'm going to max out the amps just to see what we get. Again, this is kind of a ridiculous test, but I want to see how the welder reacts. Well, I really wasn't expecting much, but I was pleasantly surprised. It actually welded rather nicely. And while we're experimenting, I'm going to play around here with this soft versus hard dial, which I think has something to do with inductance. We'll try it all the way to one side, and then we'll try it all the way the other direction. Well, either side of that seemed to weld almost the same. There was some minor differences, but to be honest with you, it's difficult for me to articulate what those were. But by appearances only, it seemed to weld okay. Let's try monkeying here with the voltage, and we'll add 3 more volts to the voltage adjustment. Well, it welded and welded decently, but the arc was a little bit unstable. So let's try doing -3 volts here and see what that looks like. Yeah, that was even worse. That was the wrong thing to do, certainly. That weld came out cold, and as you could probably see, the arc was incredibly unstable. Well, I'll go back to 0 adjustment on the voltage, max out the amps, and then leave that hard soft dial right in the center. And we'll run a couple more beads. Well, I'd say overall this thing did really good, even on the thicker stuff. I wouldn't expect there to be a lot of fusion in the root of this. Just, I'm not going to get the kind of penetration out of 030 wire that I would if I was using something like 035 or even 045. But for the most part, it did lay down. I got a little bit of undercut here on the left side, and we don't worry about the junk on the right. That was more me experimenting. But overall, I think it did fine. I would have no problem welding thicker material together with this machine as it's set up right now. Although I don't think I would use it for anything structural that might end up killing somebody if the weld fails. On this thinner stuff, I expect that I would have a lot better penetration and fusion. It's really what this setup is best at least from this particular configuration, and I was really happy with how well it welded. It was really smooth. It's a nice machine. Switching gears just a little bit, I want to show these welding squares, and it'll make sense here in a minute, that I put together some years ago. Now, I drew these up in Fusion 360, and I had the pieces cut out on a water jet, and I welded them together. I'll put a link in the description to that video. Now, yeah, these look just like the ones you can buy commercially, but I wanted to try my hand at making them, and it was a fun project. Now, when I made these first two, it gave me an opportunity to adjust the design a little bit. I wanted to make the openings a little bit wider so they would accommodate a vice grip clamp, and I made a couple of other tweaks to the size of the notches, but I never got around to actually welding them together. So I have all of the parts here to make another standard square as well as one of the multi-squares. So I think what I'm going to do is clean off the surface rust on these things and go ahead and make a project out of these and use the ArcCaptain here to put one of these together, and then we'll use the PrimeWeld to build the second one. The first set of these squares were welded with TIG, and that was primarily because I really like TIG welding. I like it actually more than MIG welding for most things, but this is a MIG welding video, so why not use it? I won't go into a lot of detail here on how these were drawn and how they go together. If you want that detail, go ahead and click on that video and take a look at that one, and you'll get a little better idea of how these are constructed. Well, that's the smaller one now completely welded. I'm going to leave it here as it is. It is square, so that's a good thing. I suppose if I really wanted to make this precise, I could stick it in the milling machine and mill off some of the bits in order to make it perfectly square. But it is close enough for what I use these for on the welding table. I will note here that I do not sell these as a kit. However, I do offer the DXF files for these on my Etsy shop. They're only a few bucks, and you can take those to your favorite water jet or plasma cutter and have them cut out a set for you. I've got them in this 8-inch size as well as 12-inch versions of these squares. Well, compared to the ArcCaptain 200, the controls on the PrimeWeld MIG 180 couldn't be any simpler. It has two knobs, one for the wire feed speed and one for the voltage, and we've got these buttons over here to change between MIG and stick as well as 2T to 4T. And unfortunately, I didn't realize it until the editing that the LED displays don't really come across on camera very well. I'll try to do some artificial adjustments in some other clips. Well, just like we did with the ArcCaptain, we'll tack together a couple of coupons and well, right after I turn on the gas, because that apparently helps when you're using wire that requires it. But we'll tack these coupons together, we'll set the machine to the recommended settings, and run a couple of passes. Well, this machine has a really nice smooth arc at the recommended settings. I might tweak these a little bit, but overall really happy with the quality of the arc and with how it sounds, and it looks like it's laying down a really nice bead. Well, I did notice right at the end of the welds I was getting a whole bunch of porosity. You might be able to see that here in this shot. And I couldn't quite figure out what the problem was. But then I realized it was coming from the fan that's inside the machine. The machine is sitting right to the left of where I'm welding, and there are some louvers on that side, and as that fan is blowing, it's blowing away my shielding gas, but only when I get to that point of the weld. I grabbed the owner's manual for the welder and I stuck it in front of that louvered vent just to prove that that's where this extra porosity was coming from. And that time I didn't get any porosity in the weld at all. So just to kind of prove this again, I'll move the book out of the way, change nothing else, and I'll run another bead and see what we get. And sure enough, as soon as I get close to that fan on that end of the weld, the porosity monster strikes again. So I guess that's an interesting lesson to learn, is to pay attention to any fans in your machines. Otherwise, you could end up with a bunch of junk in your weld that you'd have to grind out and fix. And with that book in place, it looks great. So, mystery solved. And just like we did with the ArcCaptain, we'll crank this thing all the way up and try some fat welds on this 3/8 inch plate. Well, even though that sounded really bad, and it didn't really look all that great underneath the hood, it did manage to stick these two pieces of steel together, and I can't say that the weld looks all that terrible, but again, I do expect there to be quite a lack of penetration. I'm going to turn down the wire feed speed just a little bit to see if that makes a difference. While it didn't sound great, it did lay down some metal. It's undercut quite significantly, so this would not be a good weld for structural purposes, but again, I don't think there's going to be a lot of weld penetration here with this joint. Well, because I'm here, I might as well go ahead and lay down some more metal, so we'll crank up the welder all the way back up to max here and lay some more weld down. It is spattering a lot. It is leaving lots of BBs everywhere. Again, this is just for fun. This is no real test of either of these two machines. Neither of these welds are really going to be adequate, but I wanted to see what it would do with the 030 wire. Well, I dunked this thing in some cold water here so it's a little easier to handle, to take a look at these welds a little closer. And quite frankly, both of them look okay. I did get a lot more splatter with the PrimeWeld, and I think that might have something to do with the synergic functions in the ArcCaptain. I think it adjusts the voltage a little bit while you're welding, and so you don't get as much of a unstable arc as you do with a 100% manual machine like the PrimeWeld. Of course, the advantages of having a 100% manual machine is that you can adjust it yourself. The ArcCaptain also gives you that option, so it does give you sort of the best of both worlds there. Well, I decided to channel my inner Jody, and I did a rudimentary cut and etch. And you can see neither one of these machines had a lot of penetration in the parent metal, but good enough to stick them together. PrimeWeld being on the left here in this cut. Since I used the ArcCaptain to weld together the smaller square, I might as well use the PrimeWeld now to weld together this combination square. Well, this combination square is a little bit more complicated than the other square, but it's still a pretty simple project to put together, and you don't necessarily need a lot of tools to put it together. Just need to be able to make certain that the edges are square and they don't get out of whack when you start applying some heat to them. As I mentioned before, if you want a set of the DXF files, you can get them at my Etsy shop, and also that patrons that are at the rock crawler level and above have access to all of the DXF files I make available on Etsy for no additional charge. Well, I have another project in mind that I want to use these welders with, and I'll also be able to put to use my welding squares now that I have all four of them. I have this tool shelf that's been sitting above my lathe the last couple of years. I built it out of wood when I first put the lathe here, and I really have not been very happy with it. I use it to store my quick change tool holders, which are set in these little 3D printed, I don't know what you want to call them, little mounting spots, as well as some anchor lube, some Tap Magic, and some other lubricants. But part of the problem with the shelf is it collects chips. Chips fly up on top of it, and it's a pain in the neck to clean. It's also a little tough to see which tool is in which slot. I rarely put them back in the same spot, so I have to kind of stand on my toes or start picking them up in order to figure out which tool is which. And I'd like to angle these things a little bit more toward me so it's easier to see what it is that I have. I also don't have enough spots for all of the tools I'd like to keep up here. I have a collection of them that are sitting back here behind some of them, and again, you know, they kind of just sit there. I'm concerned I'll end up chipping some carbide, and I've got these slots here for the live center and drill chucks, but I think I can do this a lot better. I've got some scrap steel left over from another project on the shelf, and I'm going to cut some of this down and we'll start welding up something new out of steel. Well, I have these sections of 3/4 inch square tube and some 3/4 inch angle and some other miscellaneous pieces here, and I'm going to use these and the welding squares here to put together a shelf with a slanted front, and I can mount my tool holders to that slanted part and then still have room for the rest of it. So to get started, we'll square up some of the outside frames here using the welding squares, and we'll start tacking it together. Since the PrimeWeld was the last machine I was experimenting with, we'll start off with that one to do some of the tacks. And as we go, we'll switch back and forth between the PrimeWeld and the ArcCaptain. Once again, remembering to turn the gas on helps a lot. These first few pieces form the frame of the bottom, where the square tube is to the front and then the angle will be on the left and the right sides. We'll take the clamps off here and I'll flip this over 180 degrees so we can weld on the square tube that'll make up the back of the bottom frame. These next few pieces make up the back and the vertical uprights of the back of the frame. With the back of the frame tacked together, we can get it clamped up to the back of the bottom of the frame and tack it into place. I'll switch over to the ArcCaptain now and do a little more assembly. I've got these horizontal parts of the upper shelf here. I started getting it tacked to the back of the frame and trying to get it nice and square, and we'll permanently tack it into place here. I have another piece of 3/4 inch square tube that I'm going to use for the front of the top shelf, and it'll also act as the top of the front slanted section where the tool holders will go. Using the small welding squares here to set them at a 45. They fit into this space really nicely, and we'll go ahead and tack this right on the edge of that piece of angle and the corner of the square tube. These slanted pieces of angle that form the left and right of the front slanted section of the shelf. With the frame completely tacked together, I can now go ahead and do some finish welding. I'll weld all of these edges solid, and I'm going to come back then later and grind them all smooth for appearances, as well as when I put the sheet steel on the front of the slanted section, I want it to sit nice and flat. Trying to give as much equal time to each of these welding machines, so I'm switching back now to the PrimeWeld, and we'll do some of the finishing on this side. I have this piece of sheet steel clamped up to the front slanted section of the shelf. We'll start by tacking it in position, and then we'll weld it in place using some 2-inch long stitches. I am going to come back later and grind these welds smooth. Well, off camera, I drilled and tapped all of the holes where the quick change tool holders will go. And I've also drilled these 4 holes on the right that I'm inserting some pipe into to hold my live center and my drill chucks. I'm going to use these pieces of expanded metal for the top shelf, and this will give an opportunity for any chips that land up there to just fall through and end up on the ground behind the lathe, and they'll probably stay there forever because I almost never clean behind there. But since some of the stuff that ends up on the shelf is not necessarily light, some of it's got a little bit of heft to it, I want to put in these 3 flat bar braces to give the expanded metal just a little bit of extra support. And since I've got the PrimeWeld in my hand now, I'm going to put a little bit of weld on the back of these pipes because the front welds are going to get ground completely smooth, and I just want to make sure that these don't happen to crack and fall out, because I don't expect, again, those welds on the front, they're not going to be super deep penetrating, and at least with these little welds on the back, if they do happen to come loose, you'll never know it because these welds on the back will keep everything in place. I also cut these short sections of pipe that I'm welding on the front, and these will be for holding things like the drill chuck keys, maybe some Allen keys or a small screwdriver. And over here on the left side of the shelf, I've got some sections of pipe that I'm going to use for storing the chuck keys for the 3-jaw and 4-jaw chuck of the lathe. Well, to weld this expanded metal to the top of the shelf, I did make one change here, and that is in the ArcCaptain, I switched out the 030 wire with a roll of 025 wire from Lincoln Electric, and I think that'll be a little bit better for welding on this thin expanded steel, because I don't want to just completely blow through it, and I think the lighter wire with much less heat will do a better job of welding it to the flat bar without blowing it all the way through. Well, that's almost all of the welding finished. The only other thing I need to do is measure and mount some flat bar on the back where this is going to mount into some studs. And then we'll give it a good clean down with some acetone, and we'll paint it, and we'll do all of that junk off camera. Well, here's the finished product, all ground down and painted with some almond enamel paint, and I think it came out great. There's even some extra room for some tool holders if I need to expand my storage a bit, and the top shelf is more than adequate for holding on to all the stuff that I normally keep up there, including a mag base for a dial indicator. Well, this is a project I've been wanting to build for a while, and it came together really nice. The only thing I had to purchase was the sheet steel on the front. I thought I had enough expanded metal, but I ended up having to buy that as well. Everything else was off the shelf, so the design was primarily dictated by what I had materials on hand, because I really didn't want to go out and have to buy anything. Steel is still pretty expensive right now to buy it off the rack, and whenever you can get cutoffs or leftovers from other projects, it's nice to have that stuff on the shelf whenever you need it. We can do a little comparison on these machines. I think overall both of them weld fairly nicely, so I really don't have anything to say there as far as how one compares to the other. But I think there's some features of the machines that we can look at side by side objectively. One of the biggest differences is that the ArcCaptain has a synergic weld. The Prime is manual only. Both machines will run as stick welders, whereas the ArcCaptain is also capable of DC lift arc TIG, where the PrimeWeld is not specified as that being an option. Although the website for the PrimeWeld shows that it only has a 10-foot MIG gun cable, it's actually 15 feet compared to ArcCaptain's 10 feet. Although I didn't use it in this video, the PrimeWeld does come standard with a spool gun. The PrimeWeld also includes a gas regulator, but if you're only using flux cord wire, it's really unnecessary. Now, ArcCaptain did send me a spool of wire, but standard in the machine, it doesn't include any, although the PrimeWeld includes a roll of ER70 and a roll of ER4043 inside the spool gun for aluminum. The cooling fan on the ArcCaptain is on demand, so you're not sitting there listening to it when you're not welding, whereas the PrimeWeld is an always-on fan. Both machines include a welding guide with suggested settings inside the door to the wire, although the PrimeWeld includes a wall chart. I will note that the ArcCaptain, all of the settings are in metric, whereas the PrimeWeld are imperial. The power cord on the PrimeWeld is a much heavier construction, and this is true for all of the cables, whether it be for the Stinger or the ground clamp or even the MIG gun itself. They were all heavier gauge wires. ArcCaptain is 2 years, where for the PrimeWeld it is 3 years. The big differentiator here is that for the ArcCaptain you have to arrange return shipping at your cost, whereas PrimeWeld will send you a replacement machine if that's necessary with the return label to put your old machine in the box and have it picked up. Being a company based in China, ArcCaptain support is limited really to email and a WhatsApp number. All of the email correspondence I've been having with them, I usually get replies in the middle of the night here in the eastern part of the United States. PrimeWeld is based in the US, so they have email and phone support, which is usually extremely responsive, and they are very present on the PrimeWeld Facebook group, so they are often responding to customer questions via social media. As far as cost, the ArcCaptain retails for $4.99 and they do offer free shipping, whereas PrimeWeld's machine is $5.99 also with free shipping. However, I do know that for the next couple of days, I think, the ArcCaptain is offering a $100 discount on their website. But I also looked on Amazon and it looks like you can get this for as low as $345 there. But in the last 3 years that I've known about PrimeWeld, they've also been running sales during Black Friday, so you can probably get this machine for even less on that day. Well, that's going to wrap up this video for now. I had a lot of fun playing with these machines and building that tool shelf for my lathe. I want to express a big thank you to both ArcCaptain and PrimeWeld for providing these machines for me to give a tryout. Now, neither ArcCaptain or PrimeWeld placed any stipulations on how I was going to review these products. The only thing I said I would do is I would produce a video for YouTube. Neither organization or representatives from them have seen this video, and maybe they won't bother watching it, but I'll give them links to it anyway. There are links to both of these machines in the description. Neither one are affiliate or tracking links of any kind. They are just straight links to their store, even though ArcCaptain did give me an affiliate code where I could get a commission. I'm choosing not to provide it. I hope you found this video useful and informative. I had a lot of fun making it, and if you did like it, give it a thumbs up. Leave a comment. Let me know what you think. Let me know what you think of these two welders. Did I get anything wrong? Is there anything I should correct? I'd love to hear from you. And a big shout out to the subscribers of the channel. If you're not a subscriber, I would really like it if you would consider doing that. And a massive thank you to the Patreon supporters who help support this channel financially and through other means. If you'd like to learn how to do that, there again are some links in the description. Thanks for watching, and we'll see you on the next one.